Hello my good people, welcome again to my YouTube channel. This is Filipino explaining. Just after we have discussed or we have learned about the concept of integration by parts, I promised you to bring you a video showing how we can apply that formula for integration by parts. So here we are. Here's a question on integration by parts. Evaluate the integration of x exponential power x dx. Here the first step is to select or to decide between x and ex, which one is u or which one is dv. So to apply the integration by parts, you need to write the integral in the form you need to write the integral in the form integration of u dv. There are several ways to do this. We can write it as integration of x exponential power x dx, where we say that this x will be our v or our u, sorry, then this exponential x dx to be our dv. Or we can write it as the same this. We can write it as the integration of e exponential power x dx. Then we can say that e power x to be our u, then x dx to be our dv. Or we can write it as integration of 1 x e power x dx, where you say that 1 is our u, then x e power x dx to be our dv. Or we can write it as integration of x e power x dx, where you can say that x e power x to be u, then dx to be our dv. Are we there? We are just writing this the same thing, the same expression here in different forms, or I can see the only difference is the bracket and the rearrangement of the portions or the factors. Are we there? So we can take either of these. We can choose either of these, but what will guide us to choose the right or to have the right choice? What will guide us? The rules that I said that we learned in our previous video, that we had the guidelines that we try letting dv be the most complicated portion of the integrand, dv to be the most complicated portion of the integrand and fits a basic integration rule. Then u will be the remaining factors of the integrand. And then the second guideline, if you can remember, it was that try letting u be the portion of the integrand whose derivative is a function simpler than u, then dv will be the remaining factors or factor of the integrand. Are we there? So if you have not watched my video on integration of by parts concept, please watch it. Then you'll find it very easy to solve this. So basing on the guidelines that I have stated, we will prefer the first option. This option, I will prefer the first option, because the derivative the derivative of the u is equals to x is simpler. I will prefer this x ex dx for x to be u, then this one to be dv, because the derivative of u, remember u is equals to x, derivative of u which is equals to x is simpler than x, is simpler than x. Remember when when we differentiate x, we get 1, right? And dv which is equals to ex dx is the most complicated, as you can see, is the most complicated portion of the integrand of this integrand. You have, this integrand have this and these portions, this portion and this portion. So this is the most complicated portion of the integrand. Are we there? So this will be our dv basing on the two guidelines that I have stated before, and fits and remember dv fits a basic integration formula. Are we there? So dv is equals to ex dx u use this, u is equals to x. So v is equals to integration of dv, which is equals to integration of ex dx, then our u which is equals to x. When we differentiate x, that is du dx, but our u is x, we get 1. When we differentiate x, we get 1. Remember the rules of differentiation. When differentiate x, we get 1. When differentiate 2x, something like 2x, for example 2x, we differentiate 2x, we get 2. This is what I mean. When we do differentiation, we reduce the power. Remember here x is power 1, so if we reduce the power by 1, so 1 minus 1, we get 0. Any number raised power 0 is equals to 1. So the derivative of u, which is equals to x, is equals to 1. Therefore this gives us du is equals to dx. Since if we multiply dx both sides, dx, we get du is equals to dx. Are we there? Then we have the integration of, to find v, we integrate dv, which is equals to e raised power x dx. Differentiation in integration of an exponential, if we integrate something like this, dx with to dx, we differentiate. When if we integrate the exponential, we differentiate the power, we differentiate the power. Are we there? Then we divide the answer that you have gotten here. The answer that you have gotten here, we divide by that. We divide the exponential by that answer. Are you getting? For example, if you have let's just use this. We have e raised power x. Remember, x here is raised power 1. Are you getting? X is raised power 1. So if we differentiate x, we reduce the power by 1, is 1 minus 1, it will be x raised power 0, which is 1. So differentiation of x is 1. So 1, the one that we have gotten, we divide it here, so that we get ex over 1, which is equals to ex. Are we there? So here will be our v will be equal to e raised power power x. Are we together? So after that, now we integrate by parts using applying the formula. Integration of u dv is equals to uv minus integration of v du. We just now substituting the values where you have integration of u dv is this. Remember, u dv. Here is multiplication, here is multiplication. So it's u dv. So we have integration of x ex dx. Are we there? Is equals to our u is x. Are we there? Then v is exponential raised to power x ax minus integration of v which is ex du dx. Remember, du is equals to dx. So we have dx. So that this gives us x ex. When we differentiate, we integrate, sorry, when you integrate e raised to power x, we get still ex. Remember, I have just explained integration of an exponential function. So this is an exponential, it's an example of an exponential function. So if we integrate this, we differentiate this, then we divide the answer that you have gotten here for differentiating the power of the exponential function, we divide it by that. Are you getting? So that this will be ex. But now in integration, we add an arbitrary constant c. So plus c. So the answer becomes x ex minus ex plus c. That's our answer. You can go further, or you can write, it can also be written as ex into x minus 1 plus c. The same thing, is just the same thing right there. So that if you multiply this and this, you get this, multiply this and this, you get this. There's no problem with that. So to check the result, you can differentiate, you can try differentiating this so that to obtain the original integrand this. If you try differentiating this, then you get the integrand this, then you know that you are correct. Are you there? So thank you so much for watching. Please make sure you do subscribe. You do subscribe to my channel, so that you don't, or you can't be left behind. Thank you so much for watching. Till next time, bye bye.